Hello students, today we want to solve the questions about moments from external past papers. The first question is the diagram shows the apparatus used to investigate moments. The apparatus are a pivot and a Newton meter, which shows the amount of the force which is used to raise it up or to keep it in equilibrium. And there is a 2 Newton weight down. This is the ruler scaled with numbers are used to show the distance between the pivot and the Newton meter and the pivot and the 2 in Newton weight. The 2 Newton weight is placed at 60 centimeter from the pivot. This is 60 centimeter, and this is the distance is 10 centimeter. I want to redraw it. This is the pivot. You may redraw any question you want. This is the force, and this is another force. The distance is 60 centimeter, and the distance is 10 centimeter. This force is 2 Newton. This force is unknown. The question wants us to state the equation linking moment, force, and perpendicular distance. You may write it as standard symbols, or you may write it as words. So moment equals force multiplied by perpendicular distance. This is one mark for this, or you may write moment equals force multiplied by distance, which is perpendicular. Now, the other side, you want to calculate the reading on the Newton meter, which is equal to F. By using what? By using principle of moment, which is clockwise equals anti-clockwise. Which one is clock and which one is anti-clock? 2 Newton, you may go down and then turn towards the pivot. This is a clock, and this is anti-clock. So clock equals anti-clock, clock, which is 2 times 60 equals F times 10. 120 equals 10F over 10 and over 10. F equals 12 Newton. Yes, 12 Newton, which is the reading of the Newton meter, but you may convert the distance, which is 60, into meters, and also 10 centimeter into meters, but you have the same answer. If you must to substitute at both sides, centimeter and centimeter, it's correct. You may convert it meter and meter, it's also correct. So without converting, it's also a correct answer. The meter rule is replaced by an iron bar. The meter rule in the previous question has what? Has no weight, no mass. But if it's iron bar, it has a weight, which is what? Which is 10 Newton. At what point it acts? It acts at the midpoint. the Newton meter and the 2 Newton weights stay in their original position. Explain how this change affects the reading on the Newton meter. First, we must to check what is the effect of this 10 Newton and where is this 10 Newton acts. We return back to this, or we may redraw it at this position. This is the pivot. This is a force which is 12 Newton, and this is a force which is 2 Newton, and the weight 10 Newton at the midpoint. This is the extra force, which is the weight of the iron bar. This force make extra clockwise moment, and the reading of a Newton meter, if it's still 12 Newton, it's not in balance. But the new reading, I want to make this as unknown force. I want to put it in UF, F in U. It must increase. Why increase? To compensate the change in the moments. Now, explain how this change affects the reading on the Newton meter. We may write it such as that. The 10 Newton lies at the right of the pivot, and it has a clockwise moment. So now we have extra clockwise moment. We need extra anti-clockwise moment if the Newton meter is still at its position. So the reading of Newton meter will increase. This is the answer. And you may what? You may find or explain that by calculation. By calculation such as what? Clock equals anti-clock. Clock, which is 10 multiplied by what? What's the distance of 10 Newton from the pivot? The length of the ruler is 1 meter, so it's 50 centimeter. And this is 60 centimeter, and this is 10. 10 multiplied by 50 plus 2 multiplied by 60 must equal F multiplied by 10. 500 plus 120 equals 10F over 10 over 10. F equals 62 newtons. So the reading of the Newton meter will increase to a very great amount because we add extra clockwise moment due to the weight of the iron bar. This is the mark scheme from the external. First mark, increase. Only if you write increase, you take 1 mark. And because the weight of the bar has a moment and in same direction or clockwise. If you write because the weight of the bar has a moment clockwise, so reading of Newton meter increase, you take 3 marks. The weight of the bar has a moment clockwise, so the reading of Newton meter will increase. You take 3 marks. Or you may shown by calculation. Shown by what? By calculation. This is another question. A man stands on the wooden board to paint a wall as shown in the diagram. The diagram shows some forces acting. What are these forces? This is the 620 Newton of the man, force X which is up, and there a force at the other support. The distance from the pivot of the man is 0.6 and the other side is 1.4. The total distance between the two supports is 2 meters. State the principle of moment. What is the principle of moment? Principle of moment states that clockwise moment equals anti-clockwise moment. Now, calculate the force X while you must to ignore the weight of the wooden board. It's light wooden board. It's massless wooden board. You must to find the force X. The same picture, it's at this point. The force X this is the pivot. There's a man and there's a force X. 620 Newton at a distance which is 1.4 meter. And this is the distance which is 2 meters. Now we may now this is the this is the anti-clockwise and this is clockwise. 620 multiplied by 1.4 must equals X multiplied by 2 over 2 and over 2. So X equals 620 multiplied by 0.7 and X equals 424, I think 434 Newton. This is the force at X. The man walks to another end of the wooden board as shown in the diagram. He is walking towards the support. Explain the change on the force X as the man is walking away from this support. As he is going towards the other support, the reaction force at this point, increase, and the reaction at this support is decrease. This is the mark scheme because the distance from pivot, which one? This is the pivot, decrease. Okay, so the clockwise moment decrease causes a force X to decrease also. Okay, why? To maintain the board in equilibrium. Okay, and I want you to solve the question and extra questions from the past papers. You may find it at the any situation on the Save My Exams or any other location, and solve questions about moments to make a good practice. And I want to thank you for listening for these lessons about moments, and I will see you in another lesson. Thank you.